Hi everyone, I am Jason, and for this experiment, we will be discussing as well as demonstrating the different basic logic gates.
For the materials, I will be using 4 ICs, an SN74 LSO4N, an SN74 LSO8N, an SN74 LS11N, an SN74 LS32N. Now, for the other materials, I will also be using some resistors ranging from 100 to 1K ohms as well as 10K to 20K ohms, a tack switch, some LEDs, a breadboard, and connecting wires, a 5-volt DC power supply, and some tweezers. After the assembly, we now have these two final products. The one I have on my left consists of parts 1 to 5, and the one I have on my right is the part 6. Before I explain the different functions of the basic logic gates, let us first establish that 1 means high level and 0 means low level. For the first part, we have 7404 or the hex inverter gate. What this does is it inverts the input, which means when your input is 1, your output will be at 0. And when your input is 0, your output will be at 1. For the next part, we have a 7432 or the OR gate. For this part, we have two inputs. And what this does is when both or either of the inputs is at 1, your output will be at 1. But when both the inputs is at 0, your output will remain at 0. For the next part, we have the 7408 or the AND gate. For this part, we also have two inputs, but the output will only be at 1 if both the inputs is at 1. When either or both the inputs is at 0, the output will remain at 0. For the next part, we have a 7411 or the triple AND gate. For this part, we have three inputs, which we will call the input A, B, and C. Now, how this works is it is similar to the 7408 AND gate, except it has three inputs. The output will only be at 1 if and only if all the inputs is at 1. For the next part, we have a combination of the 7408 and the 7432, which has three inputs as well. Input A, B, and C. Input B and C are both connected to the input of the 7408, and input A is connected to the input of a 7432. The output of a 7408 is connected to the input of the 7432. Now, as we know from the previous parts, 7408 outputs 1 when both inputs are at 1, and 7432 outputs 1 when either or both inputs are at 1. Now, for the next part, part 6, which consists of 4 inputs and 7 basic logic gates, I will be demonstrating how this works in a while. the experiment, we used the 7-4 series. And the 7-4 series are examples of TTL devices. TTL stands for transistor-transistor logic. And what that means is, for a single integrated circuit like this, there are many transistors connected inside in such a way that it will process inputs into an output depending on the logic it is designed for. Now, you may have noticed that during the experiment, there were two additional components that are not seen in the schematic diagram. These are the tact switch or the tactile switch and the 10k ohm resistor. Now, these two components are connected in such a way that it makes a pull-up switch. And what a pull-up switch does is that when the switch or the tact switch in this case is at the off state, it connects the input terminal directly to the ground using a 10k ohm resistor. Now, when the switch or the tact switch is at the on state, it connects the input terminal to VCC or 5 volt VCC. Now, for TTL devices, they do not accept an open input or a floating wire as 0. In order for the circuit to work properly, it has to be directly connected to the ground in order for it to input a 0. That is why we added two additional components. Now that wraps up for our experiment today.